Hello, everyone. Welcome to the Nathan channel. I'm your host, Nathan. If you are new, welcome. If you are not new, welcome back. Today, we're going to be talking about some of the things that I find really interesting, some of my special interests, and that is particle behavior and particles in general. I think they're really interesting. I like astrophysics, cosmology, black holes, time, gravity, all those really mind-bending concepts. I think they're fascinating, and I love to read about them and try to understand them. So without further ado, here we go. Particles in the context of particle physics and subatomic particles are fundamental constituents of matter and energy. They are building blocks of the universe and can be categorized into several types based on their properties and interactions. Here are some of the primary types of particles. This is the Large Hadron Collider where they discovered the Higgs Boson particle in 2012. The Higgs Boson particle was like this last piece to the puzzle would be called the Standard Model, which is the chart we have that shows us all different, where we organize the different particles that exist in the universe that have been discovered, and we categorize them based on their properties and their behaviors. So this was where it was discovered, in the Large Hadron Collider. It's located in Geneva, Switzerland, and it's the big particle accelerator you keep hearing about, I'm sure. This is the Standard Model before the Higgs Boson particle. I'm not sure if I have the new one here. No, but the new one is the new Standard Model graph is a circle, and it has the Higgs Boson particle right at the center, and then it has rings past that with the other particles in the universe. But without further ado, let's continue. The Higgs boson was proposed in 1964 by Peter Higgs, Francois Englert, and 4 other theorists to explain why certain particles have mass. Scientists confirmed its existence in 2012 through the ATLAS and CMS experiments at the Large Hadron Collider at CERN in Switzerland. CERN, by the way, is the Center for European Nuclear Research, just in case you weren't aware. Elementary particles, quarks. So before I get into what quarks are specifically, if you take to kind of make it easier for you to understand, if you take a proton, I know that in classic textbooks, they're described as particles that are the most indivisible part of matter, but that's not true. You can take a proton and open it up like an Easter egg, and it'll have a couple smaller particles inside of it called quarks, and those quarks have positive and negative charges, and they equate to what make up a particle. Like an overpowering positive charge from the 3 quarks means a proton. An overpowering negative charge or an equal charge could mean a neutron. An equal canceling out would be a neutron. And yeah, so quarks are elementary particles that combine to form protons and neutrons, which in turn make up the nuclei of atoms, the center of an atom. There are 6 types of flavors of quarks: up, down, strange, charm, bottom, and top. And that's what you can see in this graph here, the different designations for them, quarks here. Leptons. Leptons are another family of elementary particles, which includes electrons, muons, and tau particles, as well as their associated neutrinos. Electrons are familiar as the negatively charged particles that orbit the nucleus of the atom. So the majority of the mass found in an atom is found in the nucleus. The rest is just really empty space, and electrons are really tiny and don't make up much of the mass of the atomic structure at all. Bosons, gauge bosons. These particles mediate the fundamental forces in the universe. For example, photons are responsible for carrying the electromagnetic force, while gluons mediate the strong nuclear force. W and Z bosons are involved in weak nuclear interactions. So there are 4 fundamental forces in the universe. There's the weak and strong nuclear forces. There's electromagnetic and gravitational forces, and I wanted to also mention gluons, which you might not have heard of before. Those are, so again, if you take a proton or an a neutron, and you crack it like an egg and you open it up, there's going to be 3 smaller particles held together by these stringy looking things that are called gluons, which is kind of a nice name for it because it does glue together or hold together the quarks inside of protons and neutrons. So it's kind of a nice name. Higgs boson. The Higgs boson is responsible for giving mass to other particles through the Higgs field. It was discovered in 2012 at the Large Hadron Collider. So again, mentioning the Higgs boson particle giving mass to other particles through the Higgs field. Apparently, I don't know too much about it. I'll read more and make more videos on it, but the Higgs field is this part of our dimension where I have heard, I don't know how true this is, but I've only heard of 2 places where this happens, where particles can hypothetically go in and out of existence or go undetected, and that is at the edge of a black hole and the Higgs field. But again, I haven't done too much research looking at what happens to particles in the Higgs field, but I have heard of that. Hadrons. Hadrons are particles composed of quarks held together by the strong nuclear force. Protons and neutrons are examples of baryons, a type of hadron. Mesons are another type of hadron composed of quark-antiquark pairs. So I'm mentioning a lot of words here: hadrons, leptons, baryons. I just want to let you know a lot of the different categorizations of these particles are just based on their social behaviors. Some particles are very antisocial and they do not like to interact with other particles. Some are actually very social and like to interact with other particles, and that sometimes designates what category they go under for these names that I've mentioned. Nuclei. Atomic nuclei are composed of protons and neutrons held together by the strong force. These are not elementary particles, but composite particles found in the center of atoms. Nuclei, as you know, the center of the atom, the nucleus. Antiparticles. So for every particle, there's an existing and corresponding antiparticle of the same mass, but the opposite charge. So you have the electron behaves like an electron but has the exact opposite charge, which we call positron, I believe. And for the proton, you have the antiproton, which I think is absolutely fascinating. Antiparticles and like looking at supersymmetry and other theories of the universe is fascinating. If you find that interesting, comment down below. I want to know what you guys are interested in and what you like about these types of topics. When a particle and an antiparticle come into contact, they annihilate each other, producing energy. That's really cool. I know we have interactions between atoms that cause energy levels to vary, and sometimes it'll, like for example, if you have a particle an electron or a molecule interacting with another molecule, sometimes the electrons will bump into each other and increase or decrease their charge or energy levels, and that can cause sparks of energy or sparks of light, electricity, producing energy. But it's really interesting that a particle and its antiparticle just annihilate each other. Okay. Neutrinos. Neutrinos are low mass, nearly massless, electrically neutral particles. They interact very weakly with other matter and are produced in various nuclear reactions and particle decays. There are 3 known types of neutrinos: electron neutrino, muon neutrino, and tau neutrino. Exotic particles. These are particles that don't fit into the standard model of particle physics and are typically not observed in everyday matter. Examples include dark matter particles, which are hypothetical particles that make up a significant portion of the universe's mass, and hypothetical particles like axions and magnetic monopoles. I don't know too much about these, but I would be very happy to do research and make a video on it. I think that's very interesting. Dark matter is really fascinating because it's stuff that we know is there. We know it's present, but it's really hard to detect or see. Kind of like black holes. We know it's there, but because it absorbs light, it's really hard to detect or see from where we're standing. Gravitons. These are very hypothetical particles, but they're very interesting. The graviton is a theoretical particle that is thought to mediate the gravitational force. While it has not been observed or confirmed, it's an essential component of theories attempting to unify quantum mechanics and general relativity, which is, the theory of everything, the theory of the universe, if we ever get to a point where we can conclude that. Understanding these various types of particles and their interactions is fundamental to the field of particle physics, helping scientists unravel the mysteries of the universe, its fundamental forces, and the fundamental constituents of matter. What makes up everything, really. If you guys found this video to be interesting, please like, comment, share, and subscribe. I will be making other videos on these topics because this is my special interest, and I absolutely love talking about particles, particle behavior, black holes, gravity, time, all of those really, really, really cool topics. But yeah, make sure to share, talk to people about the channel, tell them about all the cool stuff you get to see here, and make sure to like, comment, share, and subscribe, like I said, and I will see you in the next video.